Today we are covering server virtualization for the CCNA exam, focusing on the core concepts that frequently appear in scenario-based questions. First, let's differentiate hypervisors. A Type 1 hypervisor, also called a bare metal hypervisor, is installed directly onto the physical hardware of a server. Think of VMware ESXi or Microsoft Hyper-V. They are the foundation, providing direct access to hardware resources, which means better performance. This is what you'll find in data centers. A Type 2 hypervisor, or hosted hypervisor, runs as an application on top of an existing operating system, like running VMware Workstation on your Windows laptop. For the exam, know that Type 2 is less efficient and typically used for development or lab environments, not production servers. Next, let's discuss the difference between virtual machines and containers. A virtual machine abstracts the physical hardware, and each VM has its own complete guest operating system. Containers, on the other hand, abstract the operating system itself. This means all containers on a host share the host's OS kernel, making them incredibly lightweight and fast to start up compared to VMs. The CCNA will test your ability to choose the right technology for a given scenario. If a question asks for deploying scalable microservices with rapid startup times, the answer is containers, with Docker being the platform to build them and Kubernetes to orchestrate them. If the requirement is strong isolation with different operating systems, VMs are the correct choice. Inside a hypervisor, virtual machines are connected using a virtual switch or vSwitch. This is a software-based switch that performs layer 2 functions just like a physical switch. It forwards frames between VMs and connects them to the physical network through the server's network interface cards. An exam question might involve troubleshooting connectivity between two VMs on the same host, where you need to remember that they communicate through a vSwitch, which can be configured with VLANs for segmentation. Finally, we have virtual routing and forwarding, or VRF. While VLANs provide layer 2 separation, VRF provides layer 3 separation by creating multiple independent routing tables within a single physical router. This is like having several virtual routers on one device. The CCNA often presents scenarios where a company needs to completely isolate the network traffic of different departments, like sales and engineering on the same infrastructure. VRF is the technology to achieve this routing isolation. A common exam trap is confusing VLANs and VRFs. Remember this phrase: VLANs live at layer 2 for switching, while VRFs rule at layer 3 for routing. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.